Welcome to Spelling Bee Ninja's educational podcast. We're thrilled to have you here as we explore the wonders of science together. If you're curious about the universe and how it works, this is the place for you. Make sure to hit subscribe for free enriching content that sparks your curiosity and passion for learning. Let's embark on this journey through the fascinating world of planetary motion and the remarkable discoveries of Johannes Kepler. Today, we delve into the remarkable story of Johannes Kepler, a pivotal figure in the history of astronomy. Kepler lived during the late 16th and early 17th centuries, a time when humanity was just beginning to understand the cosmos. He was a German astronomer and mathematician known for his 3 laws of planetary motion, which provided a groundbreaking framework for our understanding of the movement of planets around the Sun. Working alongside one of the greatest astronomers of the time, Tycho Brahe, Kepler was able to use Brahe's meticulously gathered astronomical data to formulate his theories. One of the most revolutionary aspects of Kepler's work was his realization that the orbits of the planets are not circular, as was widely believed back then, but elliptical. This idea challenged centuries-old beliefs rooted in ancient Greek philosophy, which revered the circle as the perfect geometric shape. Kepler's first law, the law of ellipses, states that each planet orbits the Sun in an ellipse, with the Sun located at one of the 2 foci of that ellipse. An ellipse can be visualized as an elongated circle or an oval shape. This shifting perspective allowed Kepler to accurately describe how planets travel around the Sun, showing us that even in the realm of celestial bodies, perfection comes in various forms. What may sound abstract is made clear through an interesting tidbit. The term ellipse originates from the Greek word for deficiency because an ellipse appears to be a circle that is somehow deficient in its roundness. Despite not being a perfect circle, Kepler's elliptical orbits matched observations of planetary motion perfectly and were mathematically elegant. Moving on to his second law, known as the law of equal areas, Kepler observed that a planet moves faster when it is closer to the Sun. Conversely, it travels more slowly when it is farther from the Sun. This law can be visualized in a simple yet powerful way. A line drawn from a planet to the Sun sweeps out equal areas in equal times during the planet's orbit. The significance of this law lies in the variability of a planet's speed throughout its elliptical path. When a planet approaches the Sun, it speeds up, and when it recedes, it slows down. A fascinating fact here is that the point where a planet is closest to the Sun is called perihelion, while the farthest point is called aphelion. For Earth, this difference in distance is quite notable, being nearly 3 million miles closer to the Sun at perihelion than at aphelion. This slight variation contributes to the warmer summers experienced in the southern hemisphere. Now let's discuss Kepler's third law, the law of harmonies. This law fundamentally connects the time it takes for a planet to complete its orbit with its distance from the Sun. Specifically, the square of a planet's orbital period, or the duration of one complete orbit, is proportional to the cube of its average distance from the Sun, termed the semi-major axis. To put it simply, the farther a planet is from the Sun, the longer it takes to complete its orbit. This relationship can be expressed mathematically as p squared equals a cubed, where p represents the orbital period in Earth years and a denotes the average distance in astronomical units. This equation not only reflects the nature of planetary motion but has also been instrumental for astronomers in calculating distances to planets. Kepler's third law remains relevant today, aiding the study of exoplanets and binary star systems. Kepler's journey in astronomy was anything but easy. He served as an assistant to Tycho Brahe, who possessed the most precise astronomical observations of the pre-telescopic era. Following Tycho's death, Kepler inherited an extensive collection of data, which he meticulously analyzed. Initially, he attempted to fit Tycho's observations to circular orbits, but those efforts proved futile as the data did not align. After arduous years of calculations and persistence, he discovered that elliptical orbits were the true path of planets, leading him to what he called a war with the planet Mars, as it was particularly difficult to explain. This determination reflected not only his mathematical skill but also his belief that the universe had an underlying order waiting to be uncovered. Beyond his astronomical endeavors, Kepler made substantial contributions to the fields of mathematics and optics. He delved into the mechanics of vision, explaining how our eyes work, and authored influential texts on optics. Additionally, his work in geometry, which encompassed polyhedra or three-dimensional shapes, added depth to the mathematical landscape of his time. Interestingly, Kepler also dabbled in astrology, casting horoscopes for prominent figures, including the emperor. While he didn't take astrology seriously, he viewed it as a means to support his scientific research. Initially met with skepticism, Kepler's laws provoked the disbelief of many who held fast to the concept of perfect circular orbits, a belief deeply rooted in the teachings of ancient philosophers like Aristotle. However, over time, these laws gained acceptance, particularly by scientists such as Isaac Newton. Newton's groundbreaking law of universal gravitation reinforced Kepler's findings, showing that Kepler's laws stemmed directly from his own laws of motion and gravity. This interconnectedness highlights why Kepler is often dubbed the father of modern astronomy. While Galileo may have laid the foundations for physics, it was Kepler who provided the mathematics of the heavens, forever changing our understanding of cosmic order. Kepler's life was not without personal strife. He faced significant challenges, including defending his mother against witchcraft accusations, a rare triumph as she was ultimately acquitted. Throughout his life, he battled poor health, financial hardships, and the premature loss of several children. Despite these obstacles, Kepler remained steadfast and dedicated to his scientific work, making discoveries that have shaped our understanding of the universe. Notably, after the death of his first wife, he utilized his astronomical skills to determine an auspicious time to remarry, even incorporating astrological predictions into his decision-making. Kepler published his first two laws of planetary motion in a book entitled Astronomia Nova, released in 1609. This pivotal work chronicled his decade-long struggle with Mars's orbit and culminated in the revelation of the elliptical orbit concept. A further exploration of his discoveries came with the publication of Harmonics Mundi, or The Harmony of the World, in 1619, where he introduced his third law. Kepler was enthralled by the idea of the music of the spheres, suggesting that the planets create a symphony as they travel in their orbits. In Harmonics Mundi, he even assigned musical notes to the planets, expressing his belief that the universe embodies a harmonious mathematical structure. The legacy of Johannes Kepler is profound and far-reaching. His pioneering laws of planetary motion laid the groundwork for gravitational theories later articulated by Newton. Today, these laws continue to be applied in countless areas of research, including studying the orbits of not only planets in our solar system but also exoplanets in distant star systems. This lesson reveals not just the simplifying laws Kepler discovered but also the collaborative spirit he shared with Tycho Brahe, his resilience in overcoming personal struggles, and his vision that the universe is fundamentally harmonious. Through Kepler's contributions, we learn that mathematics serves as the ultimate language of the cosmos and that relentless curiosity can unlock even the most enigmatic secrets of our existence. In today's lesson, we explored the groundbreaking work of Johannes Kepler and his three fundamental laws of planetary motion. We learned how he unveiled the intricate dance of the planets around the Sun through elliptical orbits, the varying speeds of planets in their orbits with the law of equal areas, and the relationship of distance and orbital period with the law of harmonies. Kepler's diligent analysis of Tycho Brahe's data was pivotal in these discoveries, which ultimately fostered a deeper understanding of our universe. Kepler's life also serves as a testament to resilience and curiosity, inspiring us with the notion that persistence can unlock the mysteries of the universe. Thank you for joining us on this enlightening journey through the cosmos and the life of Johannes Kepler. We hope you found this exploration of planetary motion as fascinating as we did. Don't forget to subscribe to our podcast for more captivating lessons that uncover the wonders of science and beyond. Until next time, keep questioning, keep learning, and keep exploring the world around you.